Hey everybody, Dave Schopius here. Welcome back to part 2 of my arm motor replacement. We're in the robot lab, and in part 1, if you saw it, you'll remember that this motor had burnt out because at the time I didn't know why, and it just slammed up. It just took off, ran away, and burnt the motor out. So I had taken this all off the robot. It was in pieces. I took it apart, and I was getting a new motor to install, and I think I might have shown that too, the new motor. So anyway, it's all been put back together now. I did find out what the problem was. It turned out that there was a broken wire in this circuit here coming off this potentiometer. And that is just a side note, that potentiometer is called a soft pot. It's a rotary soft pot. It looks like this. It's made by, read that, Spectra symbol. And it works by just placing pressure along this rotary part here. And depending on where you touch it, it tells you how many millivolts it is. It goes from like 5 down to 0. 5 volts down to 0. And there's I have a little stylus in here that presses up against it. It's spring operated, so it doesn't take much and it doesn't damage, and this thing will last for millions of uses, so it's amazing. So what I did is I put a new one of these on there. As long as I had it all taken apart, I put a new rotary pot, soft pot on there. I replaced the connections, replaced the cable all the way back down through to the Kangaroo. That's where it goes to, because the Kangaroo is the thing that gives the arm the position control. And it needs to be hooked up to the pot, of course, to do that. So and while I had this out, I actually put a new Kangaroo in there too, because I didn't want to take no chances. So it's everything is new. Yeah. I even put a new Easy B up here that handles the computer commands to the arm, and that's a whole nother reason I did that. I didn't like the way it was working. I had actually, full disclosure here, I shorted it out once. It didn't damage it, but I didn't trust it. Okay, bottom line, I got a new one in there, and it's all working good too. So right now we're going to talk about where I'm going to go from here. Like I said, I have everything all put back together. I have it mounted back on the robot, but it's not attached yet with the motor here that brings it in and out. So it's just sitting there. I have it just temporarily. No, it's actually fastened on there the way it's supposed to. It slides up and down this rail, so it's ready to be attached to the motor here that pulls it in and out through these cables. But I haven't got that done yet. What I need to do now, since I have a new motor, I have a new potentiometer, new shorter cables because I rerouted it away from electrical interference, and a new Kangaroo for position and speed control. This motor needs to be tuned, or I'm sorry, this Kangaroo needs to do a tune of the motor and everything involved, so it knows how fast this thing goes, how slow it goes, and where the endpoints are. So it's going to get kind of violent when I do this. I'm going to film this, so you guys don't get scared. I'm going to take some precautions here, because these are just servos that have joints on them back and forth, so I need to stiffen these joints up so they don't flop around and run all over the place and look like a wet noodle. To do that, I'm going to take this piece of aluminum bar here and when I move this up, I'm going to zip lock this underneath it and stiffen this whole thing up and give it a good rigid connection to this. So the stresses of it going up and down will be transferred all the way back here. And then I'm going to have to grab this motor because it's going to act like a diving board. As this thing goes up and down, it's going to bounce around quite a bit, and I need to stabilize that because I don't want nothing to break. So you guys keep your fingers crossed, and I'm going to set that all up and get that all strapped in, and we will do a tune of that Kangaroo back there for this motor, and we'll see how it all turns out. Okay, hang in there, stay with me, and I'll be right back. Okay, we're starting kind of at the middle of the arc for this tune. I've got it set on mechanical stops like I mentioned before. It's going to be going up and down very violently at times, so I'm going to grab this back here because it's kind of on a diving board kind of setup here. It's going to be bouncing, and I don't want it bouncing too much, that'll screw up the tune. But I have all the joints all connected and wrap lock tied so they can't flop all over the place. You see how this one here is, I think you can see this, the joints do that. That's not going to happen. I don't want those breaking, so those are all wrap lock tied. This servo is locked in, and with a bar down here, I've got that bar, aluminum bar wrapped in there, so it can't flop over and up and down. And this is what's going to be tuned right here. So wish us luck. In the past, it's been touch and go, but I already did a tune before, and it did it successfully. So keep your fingers crossed. Let's make sure this one does it again. So here we go. Mechanical tunes. Okay, we're going to pick channel 2 and continue, and I'm going to grab it. Here we go, about the tune. With any luck. Here we go. You're going crazy! Now this is what it's supposed to do. I just don't want nothing breaking, so I'm holding the... Whoop, it's finding the stops. Now it's going in between, finding the speeds. This before it went up and down, that was finding the endpoints. Now it's, I don't know what the hell it's doing, but it's doing, whatever it's doing good. As long as it keeps doing this, we're on the track. You can see why I wanted all that stiffened up and strapped down. Those servos will be going all over the place. You see the bar I have in there holding it stiff? It'll get slowly faster and faster, and then we're almost done. This is good. Tune complete. Yes! Successful tune. We have to reboot it now, and then we can see how it did. I'm sure I'm going to have to get into the PED settings and do some fine tuning, but we'll see. Okay, I'm going to pause this and unstrap everything. Alright, we're back. I have rebooted the saber-tooth and the kangaroo that is controlling this elbow and the other elbow too. So that kangaroo there, like I said, is controlling both elbows, both elbow motors. And I still have it hooked up to my computer, to the USB, so I can control it on the described software. And I've started it up. I'm going to connect and download the new settings that it found when it tuned, when it did the auto tune. We're doing that now, and boom, here we go. This is pretty much the new tune. Okay, so channel 2, and it sets the deadband and the expiration. I don't even know what the hell that is. It says exproportional. So that is just done. It's all very visual. We're more worried about positioning, and it sets all the limits for the soft and hard limits, and normal travel for this that we tuned channel 2. So that's all set. Those are all the limits that we're going to be using. We can adjust these if we want, if there's too much, or I can anyway. And then this is the live test I was talking about, where we can control it and see what we look like. First, we're going to take a peek at the controls section, and you can see here that it's set the deadband, the position deadband, at 7 millivolts, and the speed deadband at 50 millivolts. Don't ask me what the speed deadband means. I think it's however long it takes to get up to speed. So, but we're going to go into the advanced section, and you can see that channel 1 is empty because we didn't tune that. But here is all of our settings for channel 2, the one that we just tuned. This is suspect right here, the 0. Even has like a runaway detection, which is, runaway detection here, which is really nice to have, because if your motor breaks a wire like mine did before, and it'll take off. And alright, I am back. I've been having battery issues. Now I'm tethered, okay? So we don't have to worry about the battery dying. I don't even know where I stopped or where I got cut off, but basically these are the PED values that the auto-tune automatically filled. Here is the runaway detection is enabled, which is a good thing to have, because if you break a wire or something goes in and it goes haywire, it won't slam and burn out your motor like I did. One thing that's kind of suspect is a 0 right here, and that is in the fast speed gains column. We might have to change that later on. So let's see. We'll go to the live tune, the live test rather, and this is where you can tune. This is where I was at before. I tuned from here. We want channel 2, the live position test, and it wants to know if it says it needs to start. Yes. These are the positions, maximum and minimum, that it put into the system when it tuned. Just remember when it kind of went up all the way and went down all the way. So we're going to say yes to that. And this is where it's sitting right now. That's the millivolts that it's reading on that potentiometer. You see it's a little bit down. So I'm going to pay attention to the screen and not the camera. So if I scream, you know, something's wrong. Oh, here, what we want to do is come down here and show the commands too. It'll give us an idea what's going on. Oh, look at that. Okay. I am going to swing this around. You can see. Oh, okay, so that little bounce right there. You see up here in deadband. We have to make our deadband a little bit bigger back in the control section. See, it's kind of bouncing around a little bit. Up there, you see how it kind of finally got into the deadband and settled out. So let me show you what that looks like here. Okay. A little jerky, a little herky-jerky. That's nothing to worry about. I can definitely clean that all up in those PED settings. And maybe it might be just as simple as making the deadband a little bit bigger. You can see how kind of wild it is there. You're going to want to have these red and green lines kind of really scoop up and down really nice and stay in line with each other. It's going to be a pain in the butt. Well, not really a pain in the butt, but it's going to be a little tedious to get all these numbers proper, just making little corrections at a time with kind of a educated guess of which one to use. I'm going to say the position gain needs to be worked on, the fast speed gain needs to be worked on and changed. Maybe lower the power a little bit, or the minimum power, so it won't be so strong. And also what I'm going to do is come in here. You'll see that there's a speed ramping thing. I'm going to enable speed ramping on temp geometer 2 and set a speed. You see the maximum speed right now is 1590. I'm sorry, come over here. Speed limit. It's set at 1597. I'm not sure that's right either. I think these motors will go up to 3000. So we'll play with all these, and I'll come back after I've done some adjustments, and I'll show you what it all looks like and how she smoothed out, okay? Thanks for watching. Stick around. Alright, I'm back. I have been working on the PED settings and a bunch of other settings in this described program that's controlling my robot arm elbow. And I think I've got it pretty nice now. I really do. I'm really happy with it. I'm still hooked up to the Kangaroo back there, and it goes through this USB to serial adapter into my computer, just like I mentioned before. And here's describe, and let's start on the all inputs tab here, and you'll notice that channel 1 right now is filled in, and this is from the elbow on the other side over there. So I had already tuned that. I was happy with that. That's been working for years. And when this motor burnt out, like I mentioned before, I had to start from scratch. So we'll skip all that because I've talked about that. So I went ahead and got that right elbow installed into this program, and actually this program is residing on the Kangaroo. It's not in my computer, so this is just the control program running that over there. So I hope that makes sense. So anyway, this is the one I'm working on, channel 2, which is the left elbow, and I did some adjusting to the exponential. I think I might have moved the deadband a little bit. I added, you can see, here's the descriptions. Here's the speed limit. I raised the speed limit for it was like 15. I raised it to 3,000 because that's what the other motor is running at. I know it can run that high. This ramping, the speed ramping feature I enabled and set it to 2,300. That was just a kind of a, I had to play with it just so I had the proper, you know, response and everything was working good. So coming back up here, let's move over to the only ones we're going to worry about now is let's worry about the positioning. And again, this is all filled in over here for the other elbow. This is the elbow we're working on. And if you'll notice, these have all been changed. I reduced the limits quite a bit so it won't slam up against the housing when it goes up and down. It'll stop way up here and before it hits here. So I didn't want that hitting anything. Once I get the torso on, I might adjust that some more. So this has all been, these numbers have all been reduced. This is like hard limits, soft limits, and the normal travel range. And if you're interested in these, you can go to Dimension Engineering, pull up their manual for this and read all about that. So, but basically, it won't go any farther than the soft limits. Okay, that's all we're going to have to worry about right now. Let's go to the control section, and I think I raised the deadband just a touch and adjusted the speed deadband. You see over here, position deadband and speed deadband. I adjusted those. And let's go to the advanced tab. Boom. Okay. You can see that again, this is all filled in. I had all those numbers before, and pretty much these are all the new numbers. I played with these. I've been working on them for a couple days now. Actually, if you want to put in hours, maybe 8 or 9 hours, just playing and adjusting these numbers here. Remember, this was 0. That was my biggest problem. I pretty much copied this one, moved it over here, and just adjusted a little bit until my arm smoothed out. So these are the new numbers. Every motor has got different numbers, so you just can't copy and paste. Let's go do a test. Okay, here's the test. We don't have to do the tune. We've already done that. Let's go up to the live position. That's the one we're going to be working on. Yes, we want to. You see these normal travel range is greatly reduced from before. Yes, and there it is. Okay, so I'm going to just kind of hold this here, and you can see how nice and smooth that is. All the way up, all the way down, and it jerked a little bit because it's on a diving board, and everything's wobbly. No, not really wobbly, but the speed ramping will, and when everything's on there, that'll all disappear. So I can actually control it, slow it down a little bit. You can see how nice it is. No herky-jerky stuff. I can kind of... So all these movements will be handled through the computer and simple serial commands and scripts using these positions and speeds. So let me turn on this, and I'll move this around, and you can kind of see, compared before, see how it kind of, everything kind of smooth out. Notice the deadband up there? It hits it, boom, bam. And if you notice the position right here, the 2332, this is the command position where I'm setting it. Wherever I move this, that's what this will reflect, and you can see that this is the return position. So we're within 1 millivolt. Right now it's 2602 up here, the return position. The command position where I moved it to is 2602. So I'm really happy with that. That'll give me my precise positioning. Right now we're only 1 or 2 millivolts off, which is just fine. So I'm really happy. Okay, I'm going to call this part of this video, part 2, a success and a conclusion. And I will come back with a part 3 when I get everything back together and everything working good with the computer and the EZB. Okay, so what started out to be a very broken robot, and I was so upset. If you remember on part 1, I'm really happy with the way things turned out. Right, Bebel? Bebel? Bebel! It's a girl. That's my girl. She's my robot buddy. Yes, she is. All right. So I will go ahead and get this done and posted, and you guys enjoy. Bye-bye.